Okay, so in the last video we looked at ways of writing a vector in terms of these two vectors of length 1, I and j. And in this lesson we're going to see how we can use that to algebraically do some of the operations that we looked at before, like adding and subtracting vectors. Actually, before I get to that, let me just show you this nice free tool. This is Wolfram Alpha. It's wolframalpha.com is the site, and you can actually type in vectors. Like I could say I want to see 3i plus 2j, let's say, and hit enter, and it will interpret it and it'll actually plot it for you. So this little line in front here just is an indicator that this color is this vector, because you might, and I'll show you examples later on where we'll have more than one vector on there, and they just want to make sure you see which one it is. But you see we have this little 3 times I hat plus 2 times j hat. So I hat and j hat are unit vectors. They're vectors of length 1. And you can see if we add together 3i, so since I is of length 1, if we multiply it by 3, we're going to go over 3 this way. And since j is of length 1, when we multiply that by 2, we're going to go up here. So we're going to get to the point 3 comma 2. So this is kind of a nice tool to play around with these things and get a feel for what's happening, because it gets a little abstract with these, A1s and B1s and stuff. All right, so in this lesson we're going to be considering vectors A equal to A1I plus A2J, and B, vector B, being equal to B1I plus B2J. Okay, so one of the rules, well, the first rule we have here is that the magnitude of A, so we can algebraically calculate now the magnitude of A. It's going to be the square root of A1 squared plus A2 squared. It says this is just the Pythagorean theorem. So we can see that if we go back and take a look at this diagram we saw in the last lesson, that if we have a vector A1, A2, or in other words, this is A1 times I plus A2 times j, we can see that the square of this side plus the square of that side equals the square of this side, right? So Pythagorean theorem gives us the magnitude of vector A. We can do addition by just adding together the components. So we have, again, we have A is equal to A1I plus A2J. So here's A1, right? So if this is vector A. The tail of vector A is here, and we go up, the head is up here. Okay, so we can add together these two vectors. If we go, this is our j component, right? A2 times j this way, and A1 times I this way. So this is A1I plus A2j gives us A, right? And then with B, here's our tail of B and our head of B. So we go B1 times I, B2 times j to get B, right? So to get the vector A plus B, remember we said we put the tail at the tail of A, and we draw, and we set B so that its tail is at the head of A, and we to get the sum, the vector that's the sum of the two, we start with the tail of A and go up to the head of B. And we can see that this is that in the I direction we're going A1 plus B1, right? So this whole length here is A1 plus B1, and the whole height, we went up A2 and then we go up B2 more, is A2 plus B2. So if we add them together, A plus B, we just add together the components. Okay, or another way of writing it is with this, in this angle bracket notation is like this. Okay, A1 comma A2 plus B1 comma B2 equals A1 plus B1 comma A2 plus B2. And similarly, we can do subtraction. If we look at this picture over here, we have here we put the tail of A and the tail of B both at the origin here, or at the same point, and our A minus B goes from the head of B to the head of A. Okay, and that makes sense, right? If you say B plus the quantity A minus B, that's going to result in vector A, right? So if we look at what our resulting vector is, our A minus B vector, we have this total distance for the A vector is A1, right? And this total height is A2. For this vector A minus B, what happens is we're saying, okay, this distance is A1 minus B1, right? That's what's left here. And then this one is A2 minus B2. So we can just subtract the components. For vector A minus vector B, we can just subtract components. So we have A1 minus B1 times I plus A2 minus B2 times J. Okay? And let me just show you real quick what that looks like in alpha. Let's do like a more solid, like a more concrete example. If we say, let's take our vector 3i plus 2j, and put parentheses around it, and subtract, or no, let's add, and then let's add I plus 4j, let's say. Let's see if that works. Okay. So it added the two together, 3i plus 2j, or 3i plus 2j, so that's our first vector, and then we add that to the vector I plus 4j, and we get 4i, because 3i plus I, that gives us 4i, and then 2j plus 4j gives us 6j. And it shows you a picture. They use the parallelogram law to show the sum. And see, this is what I was talking about before, that the colors tell you which vector you're looking at. So here's our two addends down here, and here's the resulting vector. So we added I plus 4j, that's this guy, right? So I would just be, since I is the unit vector, it would just be going over 1, and then plus 4j, so that's this guy, and then 3i plus 2j, so 3i means going in 3 in the direction of the I vector, right? And then plus 2j, so that brings us up to here, so that's this guy. So here's our I plus 4j. Here's our 3I plus 2j. And we make a parallelogram and draw a vector from the, where the tails come together to the other end of the parallelogram. And that's our 4I plus 6j. Okay. There's some other information in here too that we'll take a look at some point. Well, vector length, we've already seen that we can just use the Pythagorean theorem. So that's what they did. What we would do here, and you can look at that yourself some more. And then there's some other things that we'll talk about in a little bit. But that's the basic idea of how this works. And you can play around with Wolfram, do some more of these, adding some together and subtracting, make sure they make sense. And let's see, for 2 points, P and Q. Okay, and then there's this other idea of a displacement from P to Q. We know that this is a difference, right? So this is since it's going from P to Q, it's the difference. It's vector Q minus vector P. So this is the displacement from P to Q.